Welcome back to our channel. Today, we're diving deep into the fascinating world of text summarization using state-of-the-art transformers. We'll show you how to fine-tune a summarization model on a custom dataset step by step. Let's get started. First things first, let's set up our environment. We'll be using several libraries from the Hugging Face ecosystem, along with a few other helpful tools. Pip install uTransformers. Pip install uAccelerate. Pip install uDatasets. Pip install uBERTviz. Pip install uMapLearn. Pip install uSentencePiece. Pip install uErlib3. Pip install Py7zr. To run this notebook first, we have to create the virtual environment and select the virtual environment for the Jupyter notebook. So create the virtual environment using this command. Python 3 mvenv. Now, let's activate the virtual environment using this command. source-bin/activate. Next, run the cell and select the virtual environment for the notebook. These commands will ensure we have the latest versions of the required libraries. Transformers and datasets are key components from Hugging Face, while others like BERTviz and uMapLearn help in visualizing and managing the data. Now, let's load our dataset. We're using the CNN_Daily Mail dataset, which is widely used for text summarization tasks. This dataset contains news articles and their corresponding summaries. From datasets, import load_dataset. Dataset equals load_dataset, CNN_Daily Mail, 3.0.0. Let's peek into our dataset to understand its structure. We'll look at the first article and its highlights. Dataset, Train 1, Article 300. Dataset, Train 1, Highlights. As you can see, the article contains a full news story, while the highlights give a brief summary. Next, we'll explore using different models for summarizing these articles. First up, let's try text generation with GPT-2. While GPT-2 isn't designed specifically for summarization, it's interesting to see how it performs. From Transformers import pipeline. Pipe equals pipeline, text generation, model equals GPT-2, medium. Input_text equals dataset, train 1, article 2000. Query equals input_text plus \NTL, dr, \n. Pipe_out equals pipe, query, max_length equals 512, clean_up_tokenization_spaces equals true. Summaries equals summaries, GPT-2, medium. 380M equals pipe_out, 0, generated_text, len, query. We prepare the input by appending TL, dr to the article. This prompts GPT-2 to generate a summary. Let's store the generated summary. Next, we use T5, a model designed specifically for text-to-text transformations, including summarization. Pipe equals pipeline, summarization, model equals T5 base. Pipe_out equals pipe, input_text. Summaries, T5 base. 223M equals pipe_out, 0, summary_text. T5 understands the task from the input text and generates a concise summary. Now, let's move on to the BART model. Hashtag uncomment to use the BART model. Hashtag pipe equals pipeline, summarization, model equals Facebook/BART_large_CNN. Hashtag pipe_out equals pipe, input_text. Hashtag summaries, BART, large, CNN, 400M equals pipe_out, 0, summary_text. BART is another powerful model for summarization. Similarly, we have Pegasus, which is highly optimized for summarizing long documents. Hashtag uncomment to use the Pegasus model. Hashtag pipe equals pipeline, summarization, model equals Google/Pegasus CNN_Daily Mail. Hashtag pipe_out equals pipe, input_text. Hashtag summaries, Pegasus, CNN, 568M equals pipe_out, 0, summary_text. Now, let's compare the summaries generated by different models. For model and summaries, print model.upper, print summaries model, print. With the pre-trained models out of the way, It's time to fine-tune a model on a custom dataset. We'll use the SAMSum dataset, which contains dialogues and their summaries. First, let's load and explore the SAMSum dataset. From datasets, import load_dataset. SAMSum equals load_dataset, SAMSum. SAMSum train 0. As you can see, each entry in the SAMSum dataset has a dialogue and a corresponding summary. We'll now prepare this data for fine-tuning. Dialog_len equals len x dialog split for x in SAMSum train. Summary_len equals len x summary split for x in SAMSum train. Let's visualize the length of dialogues and summaries to understand their distribution. I got the error. This is an interval error. Let's leave this. Import pandas as PD. Data equals PD data frame. Dialog_len, summary_len, t. Data.columns equals dialog length, summary length. Data.hist, figsize sadface 15.5. Let's tokenize the dialogues and summaries, preparing them for the model. From transformers, import auto_model for seek to seek_lm, auto tokenizer. Model_ckpt equals Facebook/BartLargeCNN. Tokenizer equals auto tokenizer.from_pretrained model_ckpt. Model equals auto model for seek to seek_lm from_pretrained model_ckpt. Def get_feature batch. Encodings equals tokenizer batch dialog. Text_target equals batch summary. Max_length equals 1024. Truncation equals true. Encodings equals input_IDs. Encodings input_IDs. Attention_mask. Encodings attention_mask. Labels encodings labels. Return encodings. SAMSum_point equals SAMSummed map. Get_feature batched equals true. SAMSum_point. Set_format. Type equals torch. Columns sadface. Input_IDs. Labels attention_mask. Next, we'll set up a data collator and the training arguments. From transformers, import data collator for seek to seek. Training arguments. Trainer. Data_collator equals data collator for seek to seek. Tokenizer. Model equals model. Training_args equals training arguments. Output_dr equals BART_SAMSum. Number_train_ethics equals 1. Warmup_steps equals 500. Per_device_train_batch_size equals 4. Per_device_eval_batch_size equals 4. Weight_decay equals 0.01. Logging_steps equals 10. Evaluation_strategy equals steps. Eval_steps equals 500. Save_steps equals 1e6. Gradient_accumulation_steps equals 16. Finally, we create a trainer object and start the training process. Trainer equals trainer. Model equals model. Args equals training_args. Tokenizer equals tokenizer. Data_collator equals data_collator. Train_dataset equals SAMSum_point. Train eval_dataset equals SAMSum_point. Validation. Trainer.train. Now, save the fine-tuned model locally on your system. After fine-tuning, let's test our model on a custom dialog and compare it with the original BART model. Trainer, save_model, BART_SAMSum_model. Pipe equals pipeline, summarization. Model equals BART_SAMSum_model. Gen_quargs equals length_penalty, 0.8. Number_beams, 8. Max_length, 128. Custom_dialog equals Lakshmikant. What work you planning to give Tom? Julie, I was hoping to send him on a business trip first. Lakshmikant, cool. Is there any suitable work for him? Julie, he did excellent in last quarter. I will assign new project once he is back. Print, pipe, custom_dialog, gen_quarks. Pipe equals pipeline, summarization, model equals Facebook/BartLargeCNN. Print, pipe, custom_dialog, gen_quarks. Here you can see the result of both fine-tuned model and original model. Fine-tuned model summarized the conversation perfectly, and the original model didn't summarize the conversation. And there you have it. We've successfully fine-tuned a summarization model and tested it on a custom dialogue. The results show how fine-tuning can tailor a model to better handle specific types of text. That's it for your video. In today's, we learn how can you fine-tune the summarization model on custom dataset. And we compare the results of fine-tuned model and original model. That's it for today's video. I hope you found it helpful. Thank you for watching. See you soon in the next video.